Right now, you are looking at a massive $7.4 billion engineering graveyard in the middle of the California desert. 350,000 cars, built with German discipline, sold with the promise of perfection, and now left to quietly decay in the heart of the Mojave Desert. But to break this silence, we need to travel to the other side of the world, to the place where everything began. This is Wolfsburg, Germany's industrial giant, 3 times the size of Monaco. The heart of German engineering beats here, across 20 kilometers of robotic production lines, where a new car rolls off the line every 16 seconds. But on a morning in September 2024, perhaps for the first time, a sound of failure rose from inside this flawless machine. As Germany's 80-year tradition of job security began to crack, factories that engineers once believed would never close were suddenly being discussed for shutdown. So how did this empire, with the most disciplined engineering army in the world, become so vulnerable to a simple software lie and a Chinese tablet manufacturer? Today, we will examine not only Volkswagen's history, but how ambition, stolen designs, and ethical blindness created a massive industrial wreckage. Fasten your seatbelts, because from inside this wreckage, we will uncover not only cars, but the shaken pride of an entire nation. I am Halil Ibrahim, a quality manager and mechanical engineer with more than 10 years of experience in the automotive industry. Throughout my career, I have personally seen how factories can operate like perfect clocks, and how one single gear inside that mechanism can sometimes paralyze the entire system. With the crisis it faces today, Volkswagen is not only questioning its own future, but also opening a major debate around the supposedly unshakable structure of the European industrial model. Today, I am not here with a classic corporate history story. In our hands, we have an auditor's notebook. On our table, we have the black box of a car. We will search for the root causes of failure, not in the robots on the production line, but in Wolfsburg's chaotic meeting rooms, and in processes that looked perfect on paper, but had ethically collapsed. How could the world's largest automobile manufacturer make such a massive engineering mistake that it had to recall millions of vehicles it had produced? The answer lies in what happens when engineering ethics are sacrificed to the ambition of winning at all costs. So, if you are ready, let us eliminate the false suspects, identify the real problems, and go back to the 0 point, the place where everything began, the year 1937. The first page of our file opens in Berlin in 1937. Volkswagen was not born as an ordinary car manufacturer. It was born as the project of a totalitarian regime, designed to buy the loyalty of the masses. The famous handshake between Ferdinand Piëch and Adolf Hitler was, in reality, the beginning of one of the greatest engineering illusions in history. In theory, every German family would be able to own a 1,000 mark people's car by saving only 5 marks per week. But beneath this perfect project lay the first ethical crime: design theft. The legendary Beetle design, mythologized for decades, was in fact taken from the ideas of Czech engineer Hans Ledvinka and Tatra. When Tatra filed a patent lawsuit over this infringement, Hitler did not solve the problem through negotiation. He solved it with tanks. In March 1939, Czechoslovakia was occupied, and the case was buried forever. Of course, the Second World War, in which millions of people lost their lives, did not begin only for these reasons. But behind the story, there was still a covered-up truth of theft. Porsche's cold confession years later became one of the clearest pieces of evidence in our file. Sometimes I looked over his shoulder, and sometimes he looked over mine. But the real tragedy was hidden inside the bricks of the factory. After the Second World War began, Wolfsburg was transformed from a car factory into a center of forced labor. Prisoners of war, who made up 80% of the workforce, were forced to work under inhuman conditions. Even more painful was the nursery facility right next to the factory, a death camp disguised as a childcare center. While their mothers were sweating on the production line, exactly 365 babies died from neglect and starvation under the factory's own roof. And what happened to the famous savings plan the Nazis had promised to the German people? The enormous fund of 280 million marks collected from 336,000 Germans was not spent on the cars promised to the public. It was secretly spent on the Nazi war machine. Naturally, no one received a car, and no one got their money back. By 1945, beneath the ruins of the factory, there was more than broken concrete. There were stolen designs, a defrauded public, and a horrifying ethical collapse. The foundation of the great crises we are discussing today had already been planted by this original sin. The year is 1945. We are standing inside an abandoned factory, reduced to rubble by Allied bombing. When the war ended, the British military administration planned to completely demolish the Volkswagen facility and sell it as scrap. For this future giant, the most painful detail was that American automotive legend Henry Ford refused to take over the facility, even for free. What changed the factory's fate was not free market demand, but the logistics and transportation needs of the occupying army. British Major Ivan Hurst realized that the machines buried under the rubble could still work, and placed an order for 20,000 Beetles for the British Army. This order stamped a permanent pattern into Volkswagen's corporate DNA. It would always have to operate at massive scale and with an obsession for absolute standardization. This strategy paid off in the 1960s. With a marketing strategy built on honesty and simplicity, the Beetle conquered the American market, and in 1972 became the best-selling car in history. But here we diagnose the first major process risk: dependence on a single product. By the early 1970s, the air-cooled rear-engine Beetle technology had aged. It had fallen completely behind new emissions and safety standards. Sales collapsed rapidly, and the company entered a serious financial bottleneck. Volkswagen solved this crisis in 1974 by creating a technical paradigm shift in the industry. The legend that still gives its name to its segment today was born: the Golf. Designed by Giorgetto Giugiaro, this car was not just a new model, it was a radical architectural transformation. Volkswagen closed the chapter of the rear-engine world and moved to a modern hatchback system with a front engine, front-wheel drive, and water cooling. With its quality, the Golf did not only save the brand from a liquidity crisis, it also gave Volkswagen the ability to manage an entire industrial group through a single platform. This group management logic reached its absolute peak in 1993, when Ferdinand Piëch took the CEO seat. To rescue the company from massive losses, Piech introduced the platform strategy, known as modal matrix, and fundamentally changed the industry. The mechanical logic was simple. Audi, Volkswagen, Seat, and Skoda models could look completely different from the outside, but underneath, they would share the same lower structure, suspension, engines, and drivetrains. This move created enormous savings of 20% to 30% in production costs and triggered an explosion in model variety that increased market share. Skoda was positioned as budget-friendly, Audi as premium. Through acquisitions such as Bentley, Lamborghini, and Bugatti, Volkswagen transformed into a technical empire. But behind this success, there was an invisible defect: a culture of pressure and fear. The flawless engineering hegemony built by Piech created a rigid vertical hierarchy inside the company that could not be questioned. In a system where failure to meet technical targets was punished, open corporate communication disappeared and was replaced by a culture of obedience, where no one could ask questions. If you build a structure where engineers cannot report risks or impossibilities to top management, the system begins to hide defects through deception. The platform strategy perfected the hardware, but it poisoned corporate governance ethics. And this poison was slowly preparing the ground for a billion-dollar explosion. The vertical and unquestionable engineering hegemony built by Ferdinand Piëch did not only affect strategic boardroom decisions, it reached directly into the design desks of R&D departments. The enormous cost savings achieved through platform sharing had blinded management with an even greater ambition for global domination. Against the rise of Japanese competitors, the order given to Wolfsburg's engineering army was clear: build a drivetrain that shifts as fast as a race car, but consumes fuel like a manual transmission. This intense pressure, and the fear culture where failure was punished, pushed one of the most revolutionary but also most problematic mechanical components in automotive history into the field before its problems were solved: the DSG transmission. Now let's quickly break down the DSG problems together. Wolfsburg's 20-kilometer production lines were sending flawless mechanical organisms into the world every 16 seconds. But the sterile simulations of the laboratory had ignored one critical variable. The real world had far too many variables. The scorching desert heat of California, or the heavy stop-and-go traffic of major cities, had already begun the first major mechanical crack that would collapse the calculations of that confident engineering army in the field. Inside the customer's gearbox, a silent time bomb was already ticking: the 7-speed dry dual-clutch DQ200 DSG transmission. As an engineer, we must perform the root cause analysis of this case by going straight into the heart of the mechatronic unit. This dual-clutch system promised flawless efficiency by reducing gearshift times to milliseconds. But to maintain that speed, the mechatronic unit had to store extremely high hydraulic pressure, between 40 and 60 bars. The engineering failure exploded exactly here, in the material selection and structural design phase. The hydraulic accumulator, or pressure tube, was directly exposed to this enormous 60-bar pressure. But the main body into which it was screwed was manufactured from a thin aluminum casting, mainly due to cost reduction. Sudden temperature changes in heavy traffic and repeated hydraulic shocks caused far more metal fatigue in the aluminum body than expected. The result was valve bodies with stripped threads and cracks, a sudden loss of hydraulic pressure, emergency mode, and thousands of vehicles stranded on the road. At first, Volkswagen failed to develop a permanent process response to this chronic design defect that had appeared in the field. Instead of accepting the fault, it pushed end users toward a complete mechatronic replacement protocol that could cost thousands of dollars. But the permanent solution that Wolfsburg's vertical hierarchy could not produce was created by the practical intelligence of the automotive industry, independent repair specialists. This practical engineering genius developed a reinforced pressure tube with thickened steel walls. Instead of throwing away the complete unit, this part completely bypassed the cracked aluminum seat and stabilized the hydraulic pressure again at 60 bars through its own steel threads. And not only that, electronic control boards worth thousands of dollars, which had been thrown away, were brought back to life through micro-soldering and component-level repair. Facing rising global warranty costs and a shaken corporate reputation, Volkswagen could not abandon the DQ200 transmission to its fate. To solve the fault at its root, second- and third-generation revision processes were launched. Engineers increased the aluminum wall thickness of the mechatronic body to prevent the metal fatigue they had seen in analysis reports. The hydraulic seat where the pressure tube was screwed in was structurally reinforced. Alongside these hardware updates, a digital shield was also added. The hydraulic pump control software was completely recalibrated. The system no longer forced the mechatronic unit to stay constantly at maximum pressure in stop-and-go traffic. Instead, it managed pressure cycles more flexibly and reduced the thermal load. By the third generation, the DQ200 was finally mechanically stabilized and began to regain confidence in the field. But saving the hardware did not eliminate the dangerous pressure culture that had existed since the Piech era. The pressure to reach targets at any cost. This mechanical victory by the engineering army opened the curtain on a much larger and much darker corporate illusion in the background. Because when Wolfsburg could not solve a hardware limitation within the boundaries of steel or through legal software calibration, its vertical hierarchy did not surrender. This time, to reach the targets, the system would search for the solution not in mechanics, but in fraudulent lines of code designed to defeat laboratory tests. Fasten your seatbelts, because now we are opening the file of the scandal of the century, Dieselgate. Right now, you are not inside a sterile laboratory test room. You are standing in the middle of the wreckage of the most organized and most audacious digital conspiracy in automotive history. Intelligent code, injected like a virus into the engine control units of 11 million vehicles, defeated laboratory emissions equipment. While on the open road, those same vehicles reached emissions values up to 40 times above the legal limit. In the mid-2000s, hybrid technology led by the Toyota Prius had established strong dominance in the American market. For the people sitting at the very top of Wolfsburg's vertical hierarchy, this was unacceptable. The order was clear. The American market had to be conquered at any cost. The weapon would be TDI diesel engines, the pride of German engineering, offering high torque and low fuel consumption. But the engineers faced an almost impossible wall, the strict nitrogen oxide, or NOx, emissions regulations of the California Air Resources Board, CARB. By the nature of a diesel engine, the high compression ratio and thermodynamic efficiency inside the combustion chamber inevitably push temperatures upward. And as temperature rises, the amount of nitrogen oxide coming from the exhaust increases sharply. When we look at the design validation map, meaning the DFMEA process, there were two rational and legal ways known in the industry to solve this mechanical dilemma. For the engineers, the options were limited. Either they would use the very costly AdBlue or SCR system, which meant sacrificing both luggage space and budget, or they would manipulate the combustion strategy inside the engine and open the EGR valve to the maximum. But although opening the EGR reduces the temperature inside the combustion chamber, it also kills engine torque and suffocates the engine with soot. Under the harsh culture of Piech and Winterkorn, where failure was punished, when engineers could not save the mechanics, they completely bypassed ethical boundaries. In the automotive industry, before a vehicle can enter mass production, it must pass the PPAP steps of the IATF standards, the production part approval process. The design's compliance with regulations is measured through standardized laboratory test protocols on chassis dynamometers. The cheating code embedded into Bosch's EDC-17 engine control unit manipulated the system exactly at this point. The algorithm constantly scanned sensor data to understand whether the vehicle was currently in an emissions test. It read the vehicle speed data, but it also monitored the steering angle sensor. If the wheels were turning and the vehicle was accelerating, but the steering wheel remained fixed at exactly 0 degrees, if atmospheric pressure and temperature data pointed to the parameters of a closed test room, the algorithm made its diagnosis. We are currently in an official test room, and it reduced emissions values dramatically. But once the test ended and the car left the laboratory for the real road, the moment the driver turned the steering wheel to the right or left, the cheating software inside the engine control unit activated road mode to deliver vehicle performance and that unshakable torque promised to the end user without compromise. The emission control systems were effectively switched off. The scandal did not explode through Volkswagen's internal audits. It emerged almost by accident through an independent field experiment by West Virginia University. Vehicles tested in real traffic with portable emissions measurement systems, known as PEMS, produced exhaust emissions up to 40 times higher than the legal limits, unlike in the laboratory. This was not an anomaly. This was a deliberate engineering project. So, as we always say, claiming the problem is in the software only covers the surface of the wreckage. When we perform a professional 5-why analysis, what do we find? Why were emissions high in road conditions? Because the software was fraudulent. Why was the software fraudulent? Because the hardware could not meet NOx limits. Why could the hardware not meet emission standards? Because the real solution, the AdBlue system, was costly. Why was cost so critical? Because there was an order in the factory for efficiency at all costs. Why could this order not be questioned? Because an empire of fear had been built, where people could lose their jobs for failure, and engineering ethics were sacrificed to vertical management ambition. A massive recall operation began, but in engineering, there is no such thing as a free solution. When you update the software and use the EGR valve more aggressively to reduce emissions, the inside of the engine fills with soot. The DPF, or diesel particulate filter, clogs. EGR valves lock. Every rework performed to clean the cheat pushed the hardware one step closer to failure. The crisis moved beyond being a company problem and turned into a diplomatic conflict between Germany and the United States. Crushed under billions of dollars in compensation, Volkswagen could not sell or easily ship millions of recalled vehicles back to Germany. Legal and logistical impossibilities condemned this enormous fleet to 37 different desert graveyards established in California. Thousands of vehicles became digital crime evidence, waiting to rust under the sun. This was not just a logistical failure, it was a monument to the ethical bankruptcy of an industry written into the desert sand. Dieselgate became a wake-up call for the industry. Europe buried the NEDC tests that looked perfect on paper and moved to WLTP standards, which measure real driving conditions. Independent verification was no longer a preference. It became a condition for survival. That desert graveyard still stands as a massive lesson, reminding us that there is no such thing as a small mistake in engineering, and that ethical blindness can bury an entire industry in the sand. While Volkswagen was trying to clean up the billion-dollar wreckage of Dieselgate and repair its damaged image with an electric vehicle offensive, the real major threat was silently growing in its most critical profit fortress, the Chinese market. Since the 1980s, the Santana had become almost a status symbol on Chinese streets and had dominated more than half of the market on its own. This created enormous arrogance and overconfidence in Wolfsburg. German management assumed that this tremendous success would continue forever. But the evolution of the digital attention economy and the radical shift in consumer behavior would force this old empire to crash into a digital wall it never expected. German engineering philosophy searched for the definition of quality and prestige in millimetric panel gaps, perfect cast pistons, and high material strength. But for the new generation of Chinese consumers, a car was no longer just a means of transportation or a mechanical display of power. It had become a digital entertainment ecosystem, where once inside the vehicle, you could almost forget the smartphone experience. Apps, videos during travel, intelligent assistants, and instant connectivity. This new customer base rejected Western manufacturers' technology as outdated. They wanted to turn on the air conditioning through a smartphone app before even entering the car, interact with AI-powered robotic assistants such as KnowMe while driving, and update the entire system remotely with a single button. Wolfsburg had severely underestimated the speed of the digital transformation of its Chinese competitors. The biggest process constraint here was software development speed and organizational flexibility. Chinese manufacturers, through strategic partnerships with technology companies and flexible R&D processes, had reached the speed of launching a new smart vehicle model from scratch within 24 to 30 months. Volkswagen's rigid vertical management system, slowed down by layers of approval, could only complete a model in 48 to 60 months. In an era where software and artificial intelligence had become the new heart of the automobile, mechanical perfection alone was no longer enough to protect scale economies. As Volkswagen's fortress in the Chinese market came under siege from technology-focused giants such as BYD, the company faced the greatest industrial Nokia moment in its history. To fight this digital backwardness, Wolfsburg made a move and gathered all software development processes under one roof by creating the multi-billion-euro software unit called CARIAD. The plan was ambitious: build an independent operating system that could compete directly with Tesla and Chinese rivals. But from a quality management system perspective, there was a serious process integration failure here. Volkswagen tried to manage software development with the same staged and rigid mechanical engineering logic it had used for hardware. The result was that approximately 12 billion euros of capital almost evaporated inside these complex processes. Software was constantly delayed. and the early versions that reached customers were full of bugs, freezes, and performance problems, causing major backlash from end users. CARIAD, which burned through billions of euros, became concrete proof of Volkswagen's failure to build a software ecosystem. By 2024, Volkswagen set aside its corporate arrogance. It admitted that it had effectively thrown in the towel in software, partially shut down the unit, and signed a massive $5 billion partnership agreement with the American electric vehicle startup Rivian. This move was an operation to buy an external lifeline. It was also the clearest confession that Volkswagen had become dependent on a startup's software architecture in order to survive. The digital wall had opened a deep wound in Volkswagen's supposedly unshakable engineering pride. The $5 billion transferred to the Rivian partnership, together with the loss of leadership in the Chinese market, triggered a chain reaction in Wolfsburg's financial ratios. For the empire that had crashed into the digital wall, the crisis was no longer just a loss of prestige. It had become a direct fight for survival. As an engineer, when we look at operational efficiency tables, we see Volkswagen's biggest structural mistake in the financial architecture of its factories, the fixed cost prison. In Germany's main factories, hourly labor costs had reached around $67, almost twice the level of some global competitors. Volkswagen's long-standing philosophy of not shifting production to other countries and protecting domestic employment had been presented for years as a source of pride. But the moment market share began to shrink, it turned into a massive fixed cost burden. Even when demand fell, these enormous operating expenses could not flex. As a result, the brand's operating margin fell to an unsustainable level of around 2.8%. Another problem we see in the analysis is corporate governance paralysis. Lower Saxony's 20% veto power within the company structure, together with the strong influence of unions on the supervisory board, made fast decision-making almost impossible in the face of operational risks. While competitors could quickly adjust production capacity and employment during crises, Wolfsburg hid behind vertical management hierarchy and legal constraints, delaying structural reforms for years. This management paralysis resulted in September 2024, when the 80-year perception of unshakable job security collapsed and historic waves of strikes began. Yet on paper, Volkswagen had a strategic plan that looked flawless: the new Auto Vision. The company promised to reduce its carbon footprint by 30% by 2030 and to transform into a fully net carbon-neutral technology company by 2050. The largest hardware pillar of this rescue plan was the unified cell battery technology developed under PowerCo. The target was to reduce battery costs by up to 50% and, by 2027, return to global dominance with an entry-level ID.1 model in the €20,000 range. We have now placed every piece of this massive industrial wreckage on the table. We began with the original sin of 1937 and the design inputs taken from Tatra. We moved through the flawless but fear-filled platform hegemony of the Piech era. We examined the aluminum body cracks of the DQ200 DSG transmission that failed in the field. We followed the trail of 11 million fraudulent engine codes that defeated laboratory testing devices and turned into a massive graveyard in the California desert. We passed through the CARIAD disaster, the $67 fixed cost trap, and corporate governance paralysis, and reached the brutal reality of today. Now it is time to close our auditor's notebook and make the diagnosis of Volkswagen. The root cause analysis of this case shows us one clear truth: technical competence is doomed to collapse unless it is supported by corporate honesty and process integrity. The real blow to Volkswagen was not simply the speed of its competitors or its shortcomings in battery technology. What damaged the empire was the unquestionable pressure culture created by vertical hierarchy, the corporate blindness that prevented engineers from reporting risks to top management, and the ambition to create scale at any cost. When people and ethics are pushed outside the process in the name of perfecting the hardware, the system inevitably begins to hide failure through deception. As a professional, the greatest lesson I have learned throughout my career is this: in engineering, there is no such thing as a small mistake. There are only potential problems that were not diagnosed in time, were covered up in management rooms, and were postponed into the future. Volkswagen, one of the world's largest automotive giants, is now proving to its own workers and to the entire world that it may be too big to die, but perhaps too heavy and too slow to change. Those hundreds of thousands of vehicles rusting beneath the desert sand will remain there as the clearest monument to the price an industry pays when it loses process integrity. Let's see whether Volkswagen can break free from this cycle and return to its successful days. Let's meet in the comments. If you have your own experiences, please share them with us as well. I am Halil Ibrahim. To avoid missing information about this and many other engineering practices, do not forget to follow my channel and watch my videos. Guided by reason and engineering analysis, I will see you in our next case file. Stay safe.